So if we were in class right now, this would be like your warm-up on the board, and I would pause for a few minutes and ask you to fill in the blanks with either the word factor or multiple. Okay, so we have these definitions earlier in your notes, and to give you a more concrete example, suppose we were referring to n as 5. Right? And then look at this example, right? 5 times 8 is 40. Would we call 40 the multiple or the factor? Would we call 5, would we say 40 is a multiple of 5 or 40 is a factor of 5? 5 is a factor of 40 or 5 is a multiple of 40? What would we say? All right, so think about that for just a minute. Pause the video if you need to and fill in the blanks. So sometimes I tell students to remember multiples are bigger, right? So if 5n divides the number, then that number would have to be a multiple of n. And any number that divides n is a factor of n. Okay, so one of the things that we're going to look at here is we're going to look at division a little bit differently. All right, and we are going to look at division as the canceling of common factors. And the other day we did prime factorization. Right? We looked at finding the prime factorization of a number. And if I were to look at this division problem, 1,260, is that divisible by 42? Right? And then I'm going to look over here at the same number and determine, is that divisible by 66? And don't forget our new symbol for divides. All right, I was using it up here and I introduced it the other day. This line here means 5 divides 40, right? So I introduced this. This is a college level way of writing A divides B. Okay, so what I'm going to do over here is I am going to do a prime factorization for all of the numbers in the problem. So why don't I write out the prime factorization for the 1,260, and while I'm doing that on your note paper, please find the prime factorization of 42 and of 66. Okay, so the prime factorization of 42. 42 is 6 times 7, so that would be 2 times 3 times 7. And then when I go to divide, we use the word cancel. We're actually not supposed to use the word cancel. We're supposed to say divides to 1. Okay, but notice 2 divided by 2 is 1, 3 divided by 3 is 1, and 7 divided by 7 is 1. And so I can see that my quotient is 2 times 3 times 5, which is 30. Okay, so I'm able to see that division using when my numbers are written out in their prime factored form. Now, over in this example, 66 is 6 times 11. So that's 2 times 3 times 11. Okay, well, if I start to try to divide, then sure, these divide to 1, these divide to 1, and notice I have this 11 down here, right? This number up here has no factor of 11. All right, so then what that tells me is that 66 does not divide the 1,260. All right, there's no factor of 11 up in my numerator, but I have this factor of 11 in what I'm trying to divide 66. So therefore, I would say 66 does not divide. I could actually use this symbol, does not divide. Okay, whereas since every factor that was in the denominator here was also present in the numerator, then I could indicate that 42 does divide this. So on the classwork, I'm going to have you write a definition for divides when I work with a fraction where I look at both the numerator and the denominator in their prime factored form. All right, and how do we write a good definition for divides? Now, let's go back to what we were doing the other day for classwork. Okay, so we were working with this number right here, n. And I was asking you to list other factors of n besides the ones that I gave you. All right, so if I were to look at some factors of n down here, all right, so I listed the obvious ones, 2, 3, 5, 7, 11, 13. Then I had listed out 10, since that was 2 times 5. I listed 22 because that's 2 times 11. 26 is 2 times 13. And so for your homework or for your classwork, you were listing out other factors. All right, so a lot of you gave me 9. That would be 3 squared. 15 is 3 times 5. 5 times 7 is 35. There's tons of possible answers. A lot of you gave me 143, right, since that was 11 times 13. Okay, but I could have gotten really crazy. Not too many of you, went crazy finding different factors, but I could do like 40, right? That would be a factor. The reason that's a factor is that's 8. 8 is 2 cubed times 5, right? I have 2 to the 4th, which means I have 3 2's that I could account for. So that would be a factor. 9 times 5, 45 would work. So again, I wish we were in class because I would have some of you list for me your factors. I could say 25 because I have 5 times 5. I could do 50 because that would be the 5 times 5 times 2. I could also do, let's see, what's 50 times 11? This computer, 550. I should have been able to do that without having to stop and think, right? Because then that would be my 5 times 5 times 2 times 11. All right, so I hope everyone sees how I'm getting these factors, right? And there's many, many other possible answers, like 49, right? 49, because that's 7 times 7. Let's see, 49 times 13, that is 637. So that would be a factor, right? And so, like I said, many, many more. So let's check out 38 then. I don't have 38 on my list, but did I just skip it over, right? Does 38 divide n? All right, and what I would look at is I would look at the prime factorization of 38. All right, and I would see that 38 can be broken down into 2 times 19. And then I look at n. N doesn't have a factor of 19. Okay, therefore 38 does not divide n, right? N has no factor of 19. So every prime factor has to be, that I have in my divisor, has to be present in n, right? Otherwise, I have to say that this divisor does not, in fact, divide n. So now let's start looking at multiples, right? What are multiples of n? And multiples of, say, 8, right? They're any number that 8 can divide, all right? And so I can just count by 8s, right? So multiples of 8, and how about I switch to a text box because that's so much easier. So multiples of 8 are 8, 16, 24, 32, 40, 48, 56, on and on forever. Okay, so I can just take 8 and I can multiply it by any other number. Okay, so if I wanted to find a multiple, another multiple of 8, I could just say, well, 8 times anything really, but any prime. Okay, 8 times 19, right? That would be a multiple of 8. All right, I've got my calculator right here, so that would be 152, right? That would be a multiple of 8. So back to here, if I wanted to find multiples of n, right, I just have to take n and multiply it by anything. And students really have a hard time finding multiples when it's really not that hard, and there are an infinite number of multiples. So we have, when I tell you on your classwork to list 5 multiples, right, you have an infinite amount of multiples that you could give me. So if I were to take n and I were to say just multiply it by 2, I would have, 2 times that, right? Well, how do I express 2 times 2 to the 4th, right? 2 to the 1st times 2 to the 4th is just 2 to the 5th, all right? And so I ask that down here. Does n divide this, right? And so now if I have n, which is 2 to the 4th, right, times, and then all the rest of this, 3 squared, 5 cubed, 7 squared, times 11, times 13, right? If I want to know if I found a correct multiple, n has to be able to divide its multiple, if it is in fact a multiple. So I'm scribbling this out because right now I'm showing this as a quotient, right? Does this number in the numerator, is this number in the numerator divisible by n, right? And it is, because I would get 2 when I divided it, right? Because all these things would cancel, and 2 to the 5th divided by 2 to the 4th just leaves me with 2. Okay, so that's how I test to see if I am, in fact, if I have in fact found a multiple. So another multiple of n is if I just took it and multiplied it by any other prime, like 19, right? So if I put n down here in the denominator, right, is this other number a multiple, right? And it is, because I can put n down in the denominator, right? And all of these things will cancel, and it will just leave me with, right, when I complete this division, it will leave me with 19. Okay, so if I take n and just multiply it by 19, I found a multiple. Or another possibility for finding a multiple is I can just take all of the prime factors in n, all of these bases, and I can just raise the exponents to something higher. Okay, because I hope you remember this rule from high school or middle school, right? I also could, if I expanded these, if I had 2 multiplied out 10 times and 2 multiplied by itself 4 times, right? And I canceled those 2's, I would be left with 2 to the 6th. So I hope you remember that rule where you just, if you have powers of the same base, you just subtract the exponents. So as long as I make these powers high enough, right, then I can subtract the exponents, and notice that I get here 2 to the 6th times 2 to the 8th times 5 to the 7th times 7 to the 8th times 11 to the 9th times 13 to the 9th. Okay, so I have found a multiple of n if I have found a number that is divisible by n. All right, if I can put n in the denominator and I can divide these and I can get a quotient, right, where every factor of n is also present in the numerator, all right, then I have in fact found a multiple of n. Whereas when I'm finding factors, right, I'm putting my factors like 45, if I want to know if that's a factor, the factors go down in the denominator, right? Is 9 times 5 a factor of n, right? The factors go down here and I see, does this in fact divide n? All right, and since it did, it was a factor. Okay, so that's the difference between factors and multiples. So if we were in class, I would ask all of you right now to try to find another multiple of this. All right, and then we would talk about it. So I'm sure some of you would say multiply it by 5, right? And so then you'd have 5 to the 4th with all the rest of it, right? Or others of you might have said, oh, just take n and multiply it by 17, right? That would work. Others of you might have said make every power 5, right? Instead of making every power 10, make every power 5, right? Because that's still big enough, right, for all of these to divide. Or, you know, some of you would have gotten creative and clever. Again, there's an infinite number of possible answers.